So page 27 is circles and lines. And this is actually the last time we're going to touch the notebook till after spring break.
Wow.
Yeah, because the next 2 units, I'm giving you a packet because it's mostly graphing.
No.
Yeah. Yep. All right.
When are we not going to?
When are we not going to graph? We're graphing for the rest of the year. On regular graphs, not polar graphs. Yeah. We'll end polar next week. By the way, your test is 1 week from today. You do not have an assessment over this unit. All right, so we're going to talk about circles and lines. All right, first thing is circles. For circles, there were 2 equations. R equals 2p cosine of theta, and R equals 2p sine of theta. Oops, I didn't mean to do 2 different 2's. And what does P tell us? Does anybody remember? The pole. How far away? So the center of the circle is P units from the pole. And also the absolute value of P is the radius. I did this graphic the other day. It will go to the right if you have what? Positive cosine. It will go up if you have positive sine. Left, negative cosine. And down, negative sine. I didn't do this with first period, but I'm going to do this real quick. If I have, let's say, let me see what example I used last year. If I have R equals negative 4 cosine of theta, how would I graph that? A what? I'm going to go left, not 4. What's my P? 2, which is your radius, remember? So I'm going to go left how many? 2. And then draw my circle. That make sense? What if I have R equals 2 sine of theta? I'm going to go up 1, that's my radius, which is your radius, and I'm going to draw my circle up, like that. Last but not least, what was the other type of case where we had a circle? No. When else did we have a circle? There was one other type of equation. There was one other type of equation that gave us a circle. R equals just a number. If R equals just a number, what was special about that? The center is at, we don't call it origin, what do we call? The pole. So like if you have R equals 3, you would have 1, 2, 3, 1, 2, 3. Make sure when you are drawing a circle, it's an actual circle and I don't know, not like a diamond or something. And that is circles. What questions do I have? Lines. How could we tell the difference between equations that were circles and equations that were lines? Anybody remember? It's not cosine and sine. Lines were secant and cosecant. Lines are the only equations that will have reciprocals. So if you look at your worksheet 2, which I'm going to have y'all pull out towards the end of class, but when you look at your worksheet 2, you can very easily look at it and see which one of these is a line. The number 5 is a line. What else is a line? 6 is also a line. So those are very easy to spot. Do y'all agree with that? All right. So lines are secant and cosecant. As a reminder, the absolute value of P is the distance from the pole. Now, what kind of line is secant? What kind of line does secant make? Why would it be a vertical line? Well, let's think. What do we know about secant? It's the reciprocal of cosine. So if I did R equals P, the reciprocal of cosine is x over r. I'm going to do r over x. If I get rid of my fraction and multiply both sides by x, I get xr equals pr. What happens? The r's cancel and x equals p. And when x equals a number, that gives us vux, a vertical line. And we get a vertical line through the polar axis. So if I tell you r equals 2 secant of theta, which direction am I going to go? to the right. 1, 2, and draw my vertical line. And it is perpendicular to that polar axis. R equals P cosecant of theta. Cosecant is the reciprocal of what? Sine. So I'm going to get R equals P R over Y. Am I going too fast? A little bit? Okay. And by the way, this is just me proving it. You're not going to have to do any of it. Like, you're just going to have to graph it. For cosecant, y equals p, which means this is a horizontal line. And if you get a horizontal line, then it is parallel to the polar axis. R equals -3 cosecant of theta. What direction would I go? Down 1, 2, 3, and draw a horizontal line. Last situation that created a line, does anybody remember? It was kind of the weird one. Then just the number, but it's not R equals, because R equals just a number is a circle. What was it instead? Theta equals. Theta equals a number. That is a slanted line through the pole. So theta equals 45 degrees. Would just be that. Questions about circles or lines? That was the easiest part of our notes. We okay? No? Do we have any questions? Give you the test. You ready? All right. Can I change it? Okay, you can put this to the side. We are now going to be working with the paper that you picked up when you walked in. And I'm actually going to go to the third one at the bottom. I'm going to start at the third one at the bottom. All right, and we're going to do lemniscates next. Has anybody ever heard of the band Limp Bizkit? That's how I remember how to say lemniscate. Kind of sounds like Limp Bizkit. Lemniscate. Okay? Lemniscates, I think, are the easiest ones, actually. Because what do their equations have? R squared. So, if you look at your homework right away, can you find all the lemniscates just by looking at it? Yeah, lemniscates are super easy to identify because they have R squared. Alright? So, you are either going to have R squared equals A squared cosine of 2 theta, or R squared equals A squared sine of 2 theta. So when you did lemniscates, what did you notice about the graph? It kind of looked like a...
What?
No, not lemniscates. It looked like an infinity sign, kind of, right? All right. How many petals are they always going to have? 2. So an lemniscate always has 2 petals. The number right here in front of theta will always be a 2. What else did you notice about the length of the petals?
Equal to 8.
It is equal to A, but what did you have to do with the number that you were given? Square root it. So in this case, I just said that number squared would give you the number, but you would square root it. So A is the length of the petal. Or the square root of A squared. There were 2 different types. For R squared equals A squared cosine of 2 theta. Petal tips are located where? They were located at A 0 degrees and where? A 180 degrees. For cosine, they were located at 0 and 180. That's an R. I don't know why. For R squared equals A squared sine of 2 theta, where were the petal tips located? Are they always going to be 45 and 225? Again, this is why we like lemniscates. They're super basic. What if what? Yeah, so I'm not going to give you a negative because if you square root it, it's imaginary. We don't go there. We love lemniscates. They're basic. So if I were to graph this, let's do an example. R squared equals 9 cosine of 2 theta. Right off the bat, you know it's an lemniscate because why? R squared. What else do I know? The petals are each going to be what in length? 3. Why 3? Square root 9. 1, 2, 3. Oh, why did I put it there? I should have. Does it go right there or does it go at 45?
No, go right there.
It goes right there because it is cosine. So always make sure, if it were sine, then you would be putting this at the 45 and 225. But because it's cosine, it's on the polar axis. No, I'm not going to be super picky. The only thing I will be picky about is please don't make it look like this. Like, don't make it pointy at the ends, like eyes. It needs to be round. Does that make sense what I'm saying? So if you have to round it out at the end, bulge your line a little bit, that's fine. Are we okay with lemniscates? We like them? Have I convinced you? They're going to be the friendliest of the group. Okay. All right, the last one we're doing today is rose curves. We're just going to go up. Can I move on? Is my pace okay now? Okay. All right. I just apologize, first period, if any of y'all are watching this. I'm sorry we started with rose curves. I think I a little bit exhausted them at 7:15 in the morning. So we're going to end with rose curves. Rose curves. How can I identify a rose curve? R equals A cosine B theta, or R equals A sine of B theta. There are two numbers. So if you're looking at, like your homework, at the end of class I'm going to have you go through and identify each type just by looking at it. If you're looking at these, this is not a rose curve Y. There's only one number. Where is a rose curve on here that has two numbers? There's no plus or minus in this. So, nope, 26 has R squared. 23, 22. There are two numbers with sine and cosine, no R squared. Does that make sense? All right. So those are rose curves. If they have two numbers, no plus or minus, and no R squared, they are rose curves. So what did we learn about rose curves? What did we learn about A? What was A? A was the length of our petals. And what about B?
How many rose petals?
Okay, always?
No, because if it's odd.
It depends, right? So if odd, what did we learn? B is the number of petals. If odd, B equals the number of petals. But what if it was even?
The double.
Not square root. 2B is the number of petals. If it was an even number, you multiplied that B by 2, and that's how many petals there were.
Wow.
And we also discovered that sometimes there was not possible to make something with a certain number of petals, right? What did not exist? 6 petals did not exist, because if you divided by 2, what'd you get? 3, and then that can't be in the equation because 3 is an odd number. 3 gave me 3 petals. All right. For A, no, not A. For R equals A cosine of B theta, bless you, the first petal always begins, where did it always begin at? At A0. Why? Because if I plug in 0 to here, what is 0 times any number? And what is the cosine of 0? No. 1. And what's 1 times A? A. That's why. Now I want to show you something that I learned after doing this. But if I type in I just typed that in. R equals 2 cosine 4 theta. And let me do it again just so y'all can see it. R equals 2 cosine. I know y'all probably could have used this like before. But instead of doing 0 to 360, if I make this a slider and do A, I kind of want to show you what happens. So, where's the zoom in button? Right here? No, that was zoom out. Where's zoom in? Thank you. Okay. If I move this at 0 degrees, it's going to, do y'all see where it starts? And I want you to watch how it graphs. What the heck? Oh, we should do the 360. Sorry. And it graphs the rose curve. So a rose curve is not actually graphed like a flower and does not go in order. It goes through, and I'm going to show you in just a minute a table to prove why it does that. But we're not going to write it down, but if you look, where are my sticky notes? I don't know where they are. Somebody took them. Okay, I'll grab this. If you look, I'm just going to plug in to, hold on, let's write this down and then I'll do it. Last thing I need you to know. The petals are always how far apart? No, that's the length of the petal. How far apart are they going to be? No?
3, 4, 5.
How could you determine how far apart each petal is from each other? What do we know about the whole graph?
It's a circle.
Oh, what do we know about a circle?
Rotation.
It's 360 degrees divided by the number of petals. Y'all, A is the length. So the petals are always 360 divided by the number of petals apart. So let's say I was graphing R equals 5 cosine of 3 theta. What do I know just by looking at this? I know the petals are 5 units. What else do I know? No. There are 3 petals. I know there are 3 petals. So I'm going to do 360 divided by 3. How far apart are each petal? 120 degrees. What else do I know? it's going to start at 5-0. Do y'all agree with everything I just did just by looking at this? So I'm going to start my graph right here at 1, 2, 3, 4, 5, 0. That's going to be my first pedal. The next pedal, I don't know where it's going to be, but I do know there's going to be a pedal at how many degrees? 120, 5, 120, and what else? 240. How do I determine where this goes next? So I'm going to show you the technical way, and then I'm going to kind of show you a trick way. Y'all cool with that? All right, the technical way is making a table and plugging in theta. Your R and theta. So 0 we just said was 5. What about, let's do pi over 3. At pi over 3 degrees, what is 3 times pi over 3? Pi. What is the cosine of pi? 0. And what's 0 times 5? So at pi over 3, it is that. All right. What about pi over 6? Oh, wait. Sorry, hold on. No, I'm going to show you a trick way. Not pi over 6. Let's do 2 pi over 3. I think I'm missing one, but let me see. 2 pi over 3. Yes. Oh, the cosine of pi is definitely not 0.
Yeah.
Somebody said 0, didn't you? What's the cosine of pi? I said that wrong. What's the cosine of pi? -1. What's -1 times 5? Thank you. Pi over 3 goes negative pi. So the next point at 60 degrees, pi over 3, you're going to go 5 away. That's where this comes from. Does that make sense? I was like, man, something's wrong right there. That is our second one. Can I start from the top? Let me do it again real quick.
Yes.
Here's our theta, here's our r. We already did 0, we know it's at 5-0, right? At pi over 3, I am plugging this into theta. What is 3 times pi over 3? 3 pi over 3, which is pi. 3's cancel, pi. What is the cosine of pi? -1. What is -1 times 5?
I like that.
-5. So then you would plot -5 away from pi over 3, which is this right here.
Is it not optimal to just count the degree?
So the reason we do this is because you probably would have selected this one as your second. It's not the second. Because if I type this into Desmos, look real quick. If I type this into Desmos, how do I zoom out real quick? And I start over here, look. Where does this go? Now, here's what I told last period as kind of a trick. I'm going to use a pencil because I'm not very good with these curves. If you start at 5-0, your next place you're going to go is the pole. You're going to kind of make semicircles with rose curves every time. And then from there, you're going to make another semicircle. And then from there, you're going to make another semicircle.
Wait, how do I know to just plug in pi?
To plug in pi. Can I zoom out? I just plugged in pi over 3. That was just me testing points out.
So you'll have to test until what?
Yeah, but what I just showed you, if you already know they're going to each be 120 apart. Do the little semicircle thing, and you'll figure out what the next one is. Okay? Okay, and now I'm going to make it. So we know our first pedal is right here. Don't make sure it's not pointy like mine kind of looks. Second pedal is there. Third pedal is over here. And there are 3 pedals. This is 1000% one of those things. Practice is you're gonna get better at it as you practice more. I'm gonna have you do at least 5 rose curves next week for you to get better at this. I'll probably do about 3 with you, and then you'll do them on your own for homework.
Wait, so there's an order of them?
The order of them matters. But, so like on your test, I think we're gonna make these 8 points each. You writing the order is gonna be like 2 points. So if you can at least figure out the length, figure out where it starts, you'll be good. Okay, here's where, unfortunately, it gets super complicated. Miss Olivares, we're not at complicated yet? We're not at complicated yet. This is where it gets super complicated. Yes. For R equals a sine of B theta, sine is different. Why is sine different? Because the first petal always begins at the pole. 0, 0. And just because it has 6 petals, well, never mind, we can't do 6 petals. Just because it has 4 petals, that does not mean each one of them is going to be at 0, 90, 180, 270. You are going to have to make a table with sine. You can't avoid a table with sine. So, let's do an example, and then I'll be done for today. I will go over this again on Tuesday, but I need you to write this down. Just by looking at this, what do we know?
The length is 4.
The length is 4. There are 8 petals. Why? Because it's even, we double it. And since there are 8 petals, what do I do? 360 divided by 8 is,
120.
they are 45 degrees apart. And where does this start at? Because it's sine, it starts at 0, 0. Well, I can start at 0, 0. That's great, but where do I go? This is why you have to have a table. Nicole, I need you to write this down. So for this table, you're going to have R theta, and whatever number is right here, whatever is your B, will be your last column. We know 0, 0 is a point. Do y'all agree with that? Okay. What you are going to do on this table is you are going to do the quadrantals. Okay? What are my quadrantals? 0. And then for theta, you're going to do 90 degrees. So if 4 theta was 90 degrees, plug in, what is the sine at 90 degrees? 1. What's 1 times 4? 4. However, that is 4 theta. What is just theta? You do have to divide by 4. What is 90 divided by 4? 22.5. So your point that you're going to plot is 4, 22.5. That is where your first petal starts. So your first petal is going to start at 0, come around like that. how do I know where the second, oh, you want me to pause real quick? I'll pause for a second. What questions can I answer about what I just did? For this right here, you're always doing your quadrantals. And then to get the middle column, you just divide by whatever number that is to get here. So what's my next quadrantal? 180. What is the sign of 180? 0 times 4? 0. What's the next quadrantal? 270. What is the sign of 270 degrees? Negative 1 times 4 is negative 4. How do I figure out the actual point, though? What is 270 divided by 4? Let's see if this will work. That's not what I did. 270 divided by 4 is 67.5. So how do I plot negative 4, 67.5? Go 4 away from 67.5. 1, 2, 3, 4. That's like right here. That's where my second petal is. What questions can I answer? Okay, there's one piece of information I've kind of ignored, but there's one piece of information that we know about this graph that I have not used. What did we say at the very beginning of this problem that I have not used? Each petal is what? Could I figure out 45 degrees between each of these? What point is this at? I'm at 22.5 right there. Could I add 45 to that? Yeah, there's going to be a petal at 67.5. Could I add 45 to that? There's going to be a petal at 112.5. Add 45 to that at 157.5. At 202, 247, which is that one that we already did, 292, and 337. If you don't know how to order the petals, do you at least know where they all are? Remember I said to make kind of semicircles? So from 1 to 2, do you kind of see what the semicircle is? From 2, where would I go next for a semicircle? Up to the 112. This is number 3. And then where would I go? Then I would go here for 4. Then where would I go? Alright, something else Ms. Gandhi taught me. Can y'all look up real quick? How many petals are between number 1 and number 2? 1, 2, 3. Do y'all see that? If I just count from 1 to 2, it's 1. It doesn't matter which way you go. Do you agree there's 1, 2, 3 petals? 1, 2, 3, that's number 3. 1, 2, 3, that's number 4. 1, 2, 3, that's number 5. 1, 2, 3, that's number 6. 1, 2, 3, that's number 7. 1, 2, 3, that's number 8. And so you can kind of keep going. If you don't get the semicircle thing down and you're not really sure what I'm doing right there with the semicircles, You can just draw the petals individually and then add the numbers later. Correct. You have to find the first two with the table. But once you find the first two, you can kind of do that trick. He's alive. He's awake. All right. Your goal this weekend. You don't have any homework due till Thursday, but you do have a 3-day weekend. What I'd like you to do is just on this blue sheet of paper, can you name each of these? Because that's what your quiz is on Wednesday. Can you name each of these just by looking at the equations? I'm going to do limaçons on Tuesday, and then I'm going to re-go over rose curves because it's Friday. It's the end of class. How much are we going to retain? So I will go over that. But by Tuesday, you need to be able to look at an equation and know if it is a lemniscate, rose curve, circle, or line.